Thanks for having me at the ZINC 2020. Today I'm going to present on this paper called Applying Survival Analysis for Customer Retention, a US regional mobile service operator. So as we know, customer retention is actually very important in telco industry. The mobile industry actually experiences an average of about 30 to 35% annual churn rate, which is actually quite significant. And it costs about 5 to 10 times more to actually recruit a new customer than retain an existing one. In this particular research, a mid-sized US regional mobile service operator was actually looking to study its customer churn profile because it wants to actually implement this proactive customer retention program. In order to do this, they want to understand when an average customer was likely to churn and how certain micro segments of these customers can actually be targeted to improve customer retention rate. The usefulness of this study can actually be applied in terms of the implementation of an data analytics survival analysis backend platform as part of a larger customer analytics solution for these kind of operators. So first, in this research, we want to understand determinants of the customer churning behavior. We first identify the key explanatory variables. And then we undertake survival analysis to predict which customers are most likely to leave and the expected duration of customers who have yet to churn. We next identify data anomalies that may be useful for actionable insights to reduce churn. We then perform customer analysis to understand the customers to target for a loyalty program and the actionable insights to conduct in terms of marketing and promotion programs to encourage customers to stay. The backend implementation-wise, we look at the construction of the analytics architecture, whether or not it's useful in terms of the customer retention solution. So for the modeling and result, in this particular case, we applied non-parametric models, your Kaplan-Meier and semi-parametric model, the Cox proportional hazard, because these do not require assumptions of survival time such as your parametricity. In this particular case, we can see that, for example, the survival time at the left-hand side shows a non-parametric distribution. There were also class imbalance issues that were not a major problem in this particular case because your isActive, which is your target variable, where event type 1 shows that the customer is active and event type 0 shows that the customer is censored or have churned. In this particular case, it's not a major issue. You can see from the graph to the right side that class imbalance is not particularly important. From the model flow perspective, data that's imported undergoes sampling stratification to reduce runtime issues. And then we run data partitioning. In this particular case, model validation was actually undertaken to identify whether if model accuracy was acceptable for basing decisions based on the model results. So we partition data 60-40 split based on training and validation data. And then we undertake the survival analysis in this case. The proportion of the Cox proportional hazard model WALT test actually indicates that the model explanatory variables were statistically significant, as we can see at the top left-hand corner of the top left-hand chart. And due to the high number of covariates, the key variable selection was actually done by rejecting variables with relatively low log-worth size effects. In this particular case, maker and deposit bin were actually heuristically selected. You can also do your own heuristical selection based on what you deem is fit. There will be a point where there might be too much analysis, so it's really up to your decision on how you want to decide on the variable selection. Kaplan-Meier is subsequently then performed. Kaplan-Meier estimate is actually a simple way of computing survival over time. It involves the computation of probabilities of occurrence of an event at a certain point in time, multiplying these successive probabilities by an earlier computed probability to get the final survival estimate. We can see here that the survival probability declined over time gradually at a median time of 4 to 5 days, with 25% percentile and 75 percentile failure rate at 294 and 913 days respectively. However, it's quite clear in the left-hand side chart that the distinct inflection point actually is observed at day 365, where survival probability fell sharply from 68.59% to 53.52%, or about 62,563 customers in this data set. So this might actually imply that there's a sharp churn that occurred at day 365 due to a particular event. Could be maybe the end of contract period. And we also observed that customers who remain with the company after day 365 were actually likely to continue with the average churn rate of about 0.3% per day. In the left-hand side chart, we see that there are some hazard function spikes that occur after the 5-year period. And because this pertains to about 5 or less customers, we ignore this post-5-year spikes due to non-materiality. And then on the lower right-hand side, we see the survival predictive model on a 30-day forward prediction basis. The survival probability histogram indicated that the top 5% of the customers would have survival probability between 0.896 and 0.995. About 56% of the customers have survival probability that's greater than 70%. And in contrast, the bottom 30% of customers would have survival probability below 50%. So we next identified the trigger points for customer churn. So in this particular section, we actually investigate the key covariates, namely the maker and deposit bin, to actually understand if there were significant differences between subvariates of each covariate in terms of customer survival rate, using the Cox proportional hazard model and the risk ratios. So the first one we look at is maker. Maker has the highest log worth amongst the selected input covariates. In this figure itself, you can see that both non-parametric log rank and Wilcoxon test results showed that there were significant differences in the survival rates between different subvariates of the variable. The level of churn risk were actually as follows, from most risky to least risky. Green, followed by yellow and orange, followed by red, blue, and then unknown. Yellow and orange appear similar in terms of risk. Their difference was statistically insignificant at 5% level of significance. Interestingly, subvariate unknown actually has the lowest risk of churn, so it might be worthwhile to actually investigate what this category implied and which clients belonged to this category. We next study deposit bin. It has the second highest log worth amongst the selected input covariates. Both non-parametric log rank and Wilcoxon test results showed that there are significant differences in survival rates between the different subvariates of deposit bin itself. Customers who placed no deposit with the banks were actually 408 times, and customers who placed less than $200 deposit with the bank were actually about 302 times more risky as compared to customers who place deposits that's greater than $200. We next look at the survival time statistics. We can see that the combined survival time statistic is actually highlighted in dark gray in the center of this table. And we can see that customers who actually have safety flag of 0, whose market is based in Seattle, whose initial monthly fee was actually 0, and whose deposit that they paid was actually greater than $200, they had a way higher median survival time as compared to the other variables. In terms of the recommendation and discussion, we look at first the top right hand table. We see that from a 30-day forward predictive model, it's worthwhile to actually target the top 62% of the loyal customers because they provide the highest benefit of about 35%. And from an overall basis, it appeared best to focus on improving customer experience at the first year from the start of mobile service, as this provided an important role in reducing customer churn as observed from the hazard rate of 21% at day 365. An optimal loyalty program can incorporate the actionable recommendations as summarized at the table to the left. As we can see here, Maker appears to actually generate adverse customer experience and increase churn. So you might want to investigate and remove this element of mobile service if possible. We might also want to implement deposits at higher amounts, for example, more than $200, because this can serve as a token fee to drive customer commitment and retention in the procured service. The other recommendations are actually in the full paper itself, so you can refer to the full paper for the full set of recommendations. In an implementation setting, the application of this study can be tied to end users. Application is actually service agnostic for service conversion triple or quad play services. Real-time user online retail interaction and network service quality of experience or QoE activity data, which can serve as predictors of churn, can be captured and analyzed. Retail store level customer touchpoint data can be obtained via Internet of Things radio sensors to monitor and communicate customer interaction. For example, higher or lower foot traffic monitoring and time of dwelling in store or over product areas. Furthermore, data that can indirectly impact customer experience, for example, inventory management, can also be extracted, such as via the warehouse IoT robotics. So this can give the opportunity to implement rich and proactive predictive churn analytical platforms with granularity down to end user level. The findings actually can form a useful guide to industry implementation of data analytics survival analysis back-end platform as part of larger customer acquisition, development, and retention analytics solution for mobile service providers. Effective implementation of recommendations can help the mobile service operator actually improve customers' length and propensity to stay and reduce customer churn, which can be hefty cost that telcos can seek to reduce. Thank you very much.